In this example, we'll find the inflection points for the given function, which is over here given as 5 minus 3x plus 3x square plus x cube. So if you are not sure what inflection point mean or the point of inflection, please watch the suggested video. Okay, so here we are going to find the inflection point at the point of inflection, but before that, as a summary, the inflection point means where the point on the curve, right, where the concavity changes. So even to figure out the point of inflection or the inflection point, we first need to figure out the intervals where the curve is concave up or down. To do that, we need to use the concavity test, right? So if you are still not sure what concavity test means, then we also need to watch that video first, okay? But as a summary, what I can say here is if the second derivative of the function is positive on certain interval, then the function is concave up. Okay, concave up. If the second derivative of the function is negative on some interval, then on that interval f is concave down. So this is the fact we are going to use first to determine where the curve is concave up, where the curve is concave down. Okay, so you might have noticed to use this concavity test, we need to first figure out where the second, what is the second derivative first, right? Then only we can determine its sign. So that's why let's try to find the second derivative. But even to find the second derivative, we first need to find out what the first derivative of this function. So let's try to find that. So what is the derivative of this first derivative of this function? What is the derivative of the 5? That is 0, right? Derivative of the constant minus what is the derivative of the negative 3x? Derivative of the negative 3x will be just negative 3. What is the derivative of plus 3x square? Just plus 6x, right? And what is the derivative of the plus x cube? That will be plus 3x square. So this is our first derivative. Our goal is to see what is the second derivative of these functions. So let's differentiate again. So find the derivative of 0 minus the negative 3. There 0 minus 3 will be negative 3. So find the derivative of that. So we get 0, right? And then plus what is the derivative of the 6x? Derivative of the 6x will be just 6, right? And what is the derivative of plus 3x square? That will be just 6x. So what we get here is 6 plus 6x as the second derivative of the given function. So if that is the case, now we need to see where this second derivative is positive, where is it negative. To do that, we're going to create the sign chart of the f double prime. So let's create a real line here extended towards negative infinity to positive infinity, okay? Now when we have that, we're going to partition this real line by using couple of information. We need to know what is the location where maybe f is undefined, but here f is polynomial, we have given that, right? So this is defined everywhere, so we don't get the partition number from there. We also need to see where the f double prime is undefined, that is also polynomial, so we don't get any partition number from there. So the only partition number here we'll get that will be useful here is where the second derivative is 0. But you can see here the second derivative function is given as 6 plus, that we have obtained as 6 plus 6x, right? So set that equal to 0 and then try to solve for x. What do we get here? We can subtract 6 on the both sides, so we get 6x equal to minus 6, and then x equal to, when we divide by 6 on the both sides, we get x equal to negative 1. It turns out that at negative 1 the second derivative is 0. We can use that as a partition number to divide the real line. So when we do that, now we have two sub intervals, one from negative infinity, right? So from negative infinity to negative 1, and then from 1 to infinity. So now over within these two sub intervals, choose some random number. Whatever random number you want to choose it. Let's say I want to choose negative 2 here and then 0, and then plug back into the second derivative to determine the sign of the second derivative. So what do you get here? What is f prime of negative 2? So since f prime is 6 plus 6x, what is f prime? F double prime at negative 2? That will be 6 plus 6 times negative 2, right? And then that will be, what will be that? 6 minus 12, which is actually a negative number, right? So it turns out that the second derivative is negative here then. So if that is the case, then what the concavity test says, if the second derivative is negative at certain interval, then it is actually concave down. So let's use this symbol here to just for a convenience later on to remember, oh, the sign was negative because of the concavity test, it's concave down. So it's immediately we can just look into that. All right, so in the same way, let's try to see when we plug, let's say on this interval from 1 to infinity, and when we plug 0 in to the second derivative, what do we get? F double prime of 0 is equal to 6 plus 6 times 0, and which is actually just 6. That means it is actually positive over there. The second derivative is positive. On that case, the curve is concave upward, right, by using this concavity test. Okay, so it turns out that f is concave down on negative infinity to negative 1. It's concave up on negative 1 to infinity. Then where the concavity changes, corresponding to this x equal to minus 1. So if that is the case, the point of inflection, or if you want to write down the inflection point, whatever you want to call it, it's the x coordinate we are able to figure out, which is actually negative 1, because here on this the x value, the concavity changes from down to up, right? But then since we are talking about the point, we also need the y coordinate. So how do we find that? Well, always if we know the x coordinate, we can always plug that number into the function to get the y coordinate. So if that is the case, let's find what is f of minus 1. F of minus 1 is 5 minus 3 times negative 1 plus 3 times negative 1 square plus negative 1 cube. I'm just evaluating the function f at negative 1, and f is over here, right? And can you check what you get here? Is it 10? All right, so if that is the case, then 10 is the y coordinate of the point of inflection, and the inflection point, or the point of inflection that we need, is negative 1 comma 10.